bunch of little ones. And then what I like to do usually with these types of questions, and what I try and get the students to do, is to write all the information in the question for a particular compound in underneath the balanced equation. So there's 25 mils of 0.10 mole per liter NaOH. Just a reminder here that capital M can be written as mole per liter. And then HCl, we know is also 0.10 mole per liter. But what we don't know is the number of mils. What we do know is that when it says completely reacts with, sometimes the question will say that. Other times it will say reaches equivalence point. And equivalence point we'll write as EP. Or other times it will say when the indicator changes color. Does anyone remember what indicator means? So the indicator is what's causing this solution in the flask to turn pink. Usually when an acid and a base are mixed together, there is no color change. For example, when you use soap to wash something that had lemon on it, there's no color change. The reason that there is a color change in a titration is because you add a solution to the flask that acts as an indicator, meaning it changes color at a certain pH. And so in this case, in the question, it could say completely reacts with, when it, like how many milliliters are needed to reach equivalence point, how many milliliters are needed to change the indicator color. All those things mean the same idea. So no matter what, we're solving it the same way. And to do that, we have to look at where do we have all the information. So here we have all the information. So we'll use that to find information of where we don't know something. And the link between the two is this idea of the equivalence point. So if we can find the moles of this, then the moles of this will also be the same. That's the beauty of a titration. Well, we can find the moles here using C equals N over V. N means mole. And we have C and V. Here's V and here's C. So C is 0.1 moles per liter, or capital M. We're looking for N, and V has to be in liters. So 0.025. To get N, we do opposite operations. So if it's divided on the right, we're going to multiply on the left. And we get a small number of moles. Okay, so there's our moles of NaOH. Okay. And then from there, we can find the moles of HCl by using the mole ratio. So here's step 1. Here's step 2. So let me make it smaller. Okay, so the mole ratio between NaOH and HCl is 1 to 1. There was only, in the balancing numbers are 1 mole NaOH and 1 mole HCl. And if I put that into my calculator, I'll get the same number. The question, though, didn't ask us about moles. It asked us about the missing milliliters to cause the concentration to change color, or the flask solution to change color. So then we can use C equals N over V again, where this time we're looking for V. But now we also have the moles, because the whole point of the titration is that the moles are equal between the acid and the base at that point, at the point where the indicator changes color. So we were given a concentration, 0.1 moles per liter. And we know that N is 0.0025. Oops. Does anyone know how we can solve for V, what I would put in my calculator?